Okay. Okay. I think yesterday's class we were discussing about smart pointers. Okay. What are smart pointers? Uh, how we can use the smart pointers in C++ to avoid memory leaks. Okay, in applications that we develop in C++. So how memory leaks generally happen in C and how we can avoid them in C++. Okay. So before that, what are the sources of memory leaks? I would just show you. Okay. So the sources, since most of you are not there, I'm just covering. I think only one person was there, I think. So in C++, you would use the keyword new to allocate or create a new object on a heap. Okay, so that on runtime you would like to allocate as much memory as possible that is needed for an object or for an array of objects that you try to create. Okay, so once you create it, you do any operations with respect to that. Post that, if you call the delete, uh, the the memory that was allocated to this object get released. Okay, so this is a general way of creating an object and deleting an object, and you avoid memory leaks if you do a allocation and release correctly. Okay, this is similar to malloc and free. Okay, so but what can happen, or what can happen in C++ or any this code is like, you can have some functions like print val. It can be in something which returns an int and all. So okay, so when it returns some int, right, you would do some evaluation, something like this. And by any chance, someone wrote a code, something, and he did return. Okay, he did a return. So what will happen? This will not be called, this deletion will not be called, and the memory associated with this is not released. And generally, these lines would be at the end of your function. And if you see, generally see, the program will be huge. People will not review your code. They will just see what you have added here. So when people don't review uh, your code and you forgot to add such things, right? That's when you can see this, all these memory leaks that has been happening. Okay. So in order to avoid such things, C++ provide uh, some alternatives like smart pointers. Okay. So what are smart pointers? Okay. So this is a general error. You create a object, but you don't delete it. So the memory should be allocated, freed by the function who is calling it. Okay. So now we'll come back to smart pointers. Smart pointers, they are like pointers. Okay, they are the same pointers of the object type which you want. Okay, the so it's a class template. Actually, it's a class templates which creates an object or a object pointer of type unique pointer, which will point to an object of type whatever class that you want. Okay, so you create a pointer or a unique pointer of this type. So the difference between pointer and unique pointer is, pointers you have to do a manual delete. Okay, whereas unique pointer or smart pointers are those type of objects which compiler will put a delete for you, releasing any such things, right? That code compiler will put for you. Okay, you don't need to write delete by yourself. The compiler would put the delete for you wherever the scope ends. So in this case, you are creating a pointer, you are using it, but the scope ends here. So whenever the scope ends, when you compile the code, the compiler will put a uh, delete operation for this pointer. Okay, it will write code for you, or it will put all those smart do all the smart operations for you. Okay, so this pointer, the memory pointed by this pointer is freed. Okay, with this concept. Now, similarly, there is an other concept wherein you create an object, but you are returning the pointer so that the other person uses this. So the calling function uses this pointer. That's an other case. So assume you have a main and you are calling a function which is this function. What he is going to do? He will create a unique pointer and return that pointer. Okay. So assuming that someone else is going to use this pointer. So this function return the pointer. Now you are doing some operations here. Okay. So once you do your operations here, you can call, actually you would you are no longer using this pointer here. Okay. So but even though you are no longer using this pointer, uh, this once compiler sees that you are no longer using this pointer, compiler will put a destructor here. Since the pointer, the compiler sees your code and understands that this pointer is still used by this function. So as long as this main function is running, so this pointer is valid, or whatever the object that you created here is valid. So once the scope ends, this pointer is freed. Okay, that's how the compiler uses or implements this garbage collections and all. So you can use this unique pointers, okay, whenever you are trying to create uh, memory, object on heap, or whenever you are trying to do any new operations. So the syntax is here: you do new of dummy for dynamic object creation. But for smart pointers, it's like make unique followed by dummy followed by so what constructor that you want to do. So now for any reason, this guy is taking some parameters. Okay. Okay. So if you have a class which is taking some parameters as an argument, you can pass the same here. So the corresponding constructor will be called, and the pointer will be initialized to point to that object. Then you can use it, and once you are done, the compiler will write the code to release the object. So that's a recap of this. I think it's just a small recap. I'll upload the videos, so I have executed and shown how it does. Maybe then you would understand the unique pointer concepts. So this is something which every interviewer will ask: what is pointer? What is unique pointers? Okay, and whoever is interviewing you on C++, he will definitely ask this question for sure. Okay. Anyone has ever used such thing like unique pointers so far? Okay, that's a silent. Okay, uh, maybe I'll continue with next one. Okay, so the next topic that I want to cover is this pointer. So what is this pointer in a class? Okay, so this pointer is it's a keyword. Technically, this is just a keyword. Let me write down. Is a keyword provided by compiler to specifically point out uh, or uh, or or refer to variables of the object. Okay, of the object on which you are doing some operation. Okay, so it's a big statement. Okay, so I'll explain you so that over an example. So that's when you will understand this. Okay, so okay, consider this main function. Okay, so in this, I'm creating and I have a class by name dummy. Okay, in this, see this one. There are two types of objects creations. One is non-parameterized, okay, default constructor, and other one is constructor with an argument, okay, which takes an argument. So the other one doesn't take any argument. Now we'll see how these two are have written in a different way. Okay. Now if you see this, right, I have created a class, okay, dummy. What it does is whenever you create an instance of it, it will just print objects with instance, and it will just have a static variable, and you're just incrementing it. So it's the same class that we are taking from previous classes, wherein whenever you create an instance, it will just do an increment on static object. Okay, so now whatever the value that you assign here is copied to this index. Okay, so now the difference between this and this is, now both are constructors. Now this guy is taking an index. Okay, and that now he's taking an argument by name index. Okay, now suppose in your class, you have a variable by name index. I repeat, suppose in your class you already have a variable by name index. Okay, and you have a function which is taking an argument by name index. Okay, so what happens here? There are two indexes. This, which is passed as a parameter, okay, and other one is what you have as part of your class. Okay, so first one is which is passed as a uh, okay. The second index is part of the second index is part of the class or object already. Okay, now what happens, like compiler will be a bit ambiguous, like if you do this something like this. Okay, now what can happen here? You can't tell whether this content of this is copied to itself, or content of this is actually being copied to your instance index. Okay, so whether you are copying the content to your variable or not, you cannot tell, or you cannot assure this. Okay, now how compiler will treat it or will parse it will become very difficult to understand. So in order to isolate such problems, okay, we can use this pointer. This uh, uh, actually this is a pointer. So how do we use this? A pointer is just a dot and arrow by index. So this is used to specifically reference the local variables that this class has. Okay, no, not just this, you can do any other operation. Now if you have renamed it to some number, okay, you can use this as well. Okay, no problem. Okay, so basically this pointer is generally used to uh, specifically say I am referring a variable which is part of my class. Okay, this one. So far, any doubt on this, or did okay? Anyone had any questions? Yes. I hope you all understood, right? So this pointer is generally used to refer and specifically say I'm trying to refer contents of this variables of this class. Okay, but there are certain limitations with this class. Okay, okay. Before going to the limitations, we'll try some operations here and see what it actually does. Okay, so what this program does is he just create three objects. He just create three objects and prints what is the instance of it. Okay, object dot this should print one. Object two, we have passed a number as two, so it will save the number as two and print. Now object three is the third object, so it will print the instant as three. Okay, okay. Now if you see here, object with instance one got created and two got created and three got created. Okay, now instance it is still printing as three. Just small correction. I'll do it. Okay, okay. I'll repeat this function. So what this function will do is he's going to print what is its instance out of total number of objects that it got created. Okay. Now if you see here, one, two, three. So it created a three objects. The second one is taking index as two. So what is the difference between first and second? He is taking the index as two and assigning it and saving it. Okay, and it's just printing the instance of it. Okay. Now, by any chance, if you want to override this to 20, so what will happen? Okay. Now you just want to say, let's see what happens. You are not you're just given a some random number to this. Okay, but so it is like some dummy index that you have assigned. Okay, so the second object that you created, the created had a unique number as 20. You gave it as 20. Okay, and you printed the what was the instance number, or what is the unique number that you have assigned to it. So for the second object, whatever the unique number that you have assigned, right, it is stored here, and it is just printing. It is 20 out of three objects or three out of three. Okay, and post that they all got destroyed. Okay, so what I wanted to show here is just even though the names are same, index and index. Okay, with the help of this pointer you are able to separate, like this value is actually assigned to this and you are actually printing it. okay, and you are not seeing any issues like this value being not assigned or something like that. Now let's see if I remove it, what happens. It can, so it get compiles. See, now if I remove this here, what is happening? Object with instance 2 and index value is some junk. Okay, so if you see here, I am printing this dot index. Now what it got print? Some junk value, because this index you are not initializing it anyhow anywhere. Okay, so what compiler did is he took this and copied it to itself. So it's like it took this value and assigned to the same variable, but that is not what we wanted. What we wanted is this value should be assigned to this variable. Okay, to help us achieve that, what we can do, we can explicitly say I want to copy this content of this variable into this index. So now what we can do is, now if you see whatever the value that you passed, okay, whatever the value that you passed here is copied. Okay, so I'm clear, guys. Any doubts on this? Group or Subbu or Alisa, any doubts? Clear, right, on this?
No.
Yeah, you have any doubts on this? You said no, right? I mean, are you not clear or you don't have any doubts?
No, I don't have any doubts.
Okay, thank you. Okay, next, the next use or complication with this pointer is, okay, suppose you have a class which has uh, static member functions. Okay, you have a class which has a static member function. Okay, the static member function cannot access this pointer. Okay, why? When I say static member cannot access this pointer, why? Because static member functions, okay, they are not actually part of the class. Okay, these functions are just declared within the class scope. They are just declared within the class scope, and they will have access to the static members of the class. Okay, that's all. But they will never have access to non-static members. Okay, so they are basically like global functions, okay, which have access to the static members of this class and other global variables. Okay, and you can call this function even without an object is being created. Okay, so I think when I explained the static member function previously, I would have shown you, right, uh, something like this. I would have called a function, a static member function, even before object has been created. Okay, I would have shown you that where you are trying to call a member function even before object has been created. Okay, so this is nothing but a normal global function where you are calling. So okay, so when you're calling this function, there is no assurance. There is no assurance that an object has been created. Okay, so when there is no assurance that an object has been created, it doesn't know to which variables, to which it should point. Okay, so that's why any static member functions will not have access to the this pointer. Okay, so in this example, print static val is a static member function. Okay, this is a static member function. Okay, inside this, if I try to call this dot print value, it will show some error. Okay, it will show some error. But the same function, if I try to call in non okay, in non-static function, I'll not. No, okay, sorry. If I using this pointer, I can call any other functions which are not static. Okay, I would not see any error. Okay, but if I'm trying to call the same function here, I will correct my code. Okay, now if I try to call the same function inside a static function, I would see some error. I hope you are able to understand this one, right? I'm just calling the function by name get my instance. Okay, now without this, can I call? Yes, I don't see any error here. I can call it. Even in a destructor, can I call it? Yes, I don't see any error. But okay, if the moment I call this function inside a static member function, it shows us error saying a non-static member reference must be related to a specific object. So he doesn't know on which object he is trying to do this operation. So he's not able to call it. Okay, that is one limitation of this pointer. So static functions cannot call this pointers. Okay, but how can you call these functions? Okay, how can you call these functions is, so it, in order for you to call these functions, right, you should tell the compiler on which object you are trying to make the change. Okay, so you should pass the object as a pointer. Okay, you should pass object as a pointer, and on that object, if you call get my instance number, you would not see any errors. Okay, so the static functions need a reference of an object on which you are trying to call based on non-static member functions. Okay, that's one that's a way that you can solve the problems that you see. So I'll remove the code that I added. Okay, I'll show this destructor. I'll show how we can call this. Okay, so okay, so in my main, I have created 3 objects. Okay, let me keep it as okay 1, 2, 3. Let me call a static function. Now this is a static function which is member of this class. So to which I am passing object 3. Okay, to which I am passing the object 3. Now what will this do? It will come here. It will take object and object ka get my instance number we can call. So you can't put this here and use it. So you have to generally use the uh, objects ka reference. Now let's compare and see what it does. Okay, now if you see, right, what is the code? So object with instance 1 created, objects with instance 2 created, 3 created. That is output of line number 12. Now I didn't do a save. Okay, so object 1 2 3 1 2 3 got created. Okay, that is because of this. Next, get my instance, get my instance, get my instance. So we just printed what is the instant of 1 2 and 3, these three objects. Then I call this function print static val. Okay, so here if you see, right, I'm just calling a static function. I'm not using anything like object1 or obj2 or obj3, but I'm passing the instance object on which I need to do some operation. Now object3 I'm passing as reference. What he is doing, he is taking the object and he is printing his instance. Okay, he is printing his instance. Now what should it should be object3's instance. So the output of this should be equivalent to what you saw here. So it is this. So this was the output of line number 15. Now output of line number 17 is these three. Inside that you see a line this, which is equivalent to this, because compiler is just calling this function that we actually added. Okay, so that is one. Second one that I wanted to help let you know. So why we use this pointer and how to overcome this pointer, the limitations that we have for this pointer on static member functions. Okay, these two part I wanted to explain. So the any questions on this so far?
No, sir.
Okay, thank you. So now what more can we do? Okay, what more can we do with the help of this pointer? Okay, so this is a pointer, right? So since this is a pointer, you can do any operations that that is allowed on the pointer. Okay, like I can write a function to destroy. So destroy. So generally destroy means releasing, something like releasing or free. So this is something unique. Okay, so what it does is it destroys itself. So you can write a code to destroy itself. Okay, maybe if you guys are RTask programmers, right, you would see create task, run task, delete task, pen task, post task, and all. Like you would see the state like delete self or delete task or something similar. Okay, something similar to that. It can delete itself. Okay, you can do any operations on this. This what this does is this just returns the address. Okay, this will just return an address and compiler will blindly call delete on that. Yes, that's all is what it does. Okay, now let's call this. Is it possible to do it? Okay, now so one thing that you need to see is whenever you are using Okay, so whenever you create an object, right? Okay, you can actually write for something like this obj4. Okay, you can actually write code something like this, or if you don't if you don't, okay, typical coding, okay, you don't like the, you can do this. You can do something below. So what here you do is you would write some destroy operations on top of this. Okay. So now what this will do is it will delete this object and will blindly return here. Okay. So let's see whether this thing goes good or not. There's no member destroy. Okay. So it is giving some. This. This is not taking argument. Void dummy destroy. Okay, something junk. Okay, now if you see this code got compiled wherein you just created and you called a destroy. Now let's see the destructor of this is called. Now what is a, sorry, okay. Now what is the output? If you see object with instance one got created and object with instance one got destroyed. So the new is actually creating this object. Now you said you wrote a function by name destroy. Okay. Now what destroy does? Destroy will do a delete on this. Now what does this do? This will just call the destructor of this function. So we're just calling the destructor of this object. Okay. So why would someone write a destroy function? Any guesses? Why would someone write any destroy functions? Anyone? Why would anyone write a destroy functions?
I think to free the memory.
I agree. That is for that you can do just delete, right? For that I can just write a delete obj4, right? Now, why would someone specifically write destroy something like this? So you need not just do a delete here. Okay, you need not just do a delete here inside the destroy. You can do something like take backup, release something else. Once everything is done, okay, if everything is good, then you can call delete. Okay, if something is bad, you can throw exception. Okay, so you can use you can write your own destroy functions wherein you can take a backup. Take backup means assume here I have these two variables, static and int. Okay, if I want to store this content to somewhere, okay, I can write a destroy functions and they take backup here. So every time I don't need to write a code saying obj take backup, do error check, etc. and all, and okay, and then I do a delete. Okay, so I don't want to do write such code again and again. Okay, so here I just have a main function and there is only one instance created. Okay, if what if there are multiple instances that created, something like this, then for everyone I need to call obj 2 dot backup, 2 dot error check, 2 dot something else, and then delete obj2. And for obj3 I need to call the same again and again. Okay, to avoid all those things you can call a destroy function. Okay, so there inside that you will do whatever customization that you want. Okay, you can take backup, release something else, and if you see everything got released and you are normal state, you can just do a delete. Okay, if something is bad, you can throw some exceptions. I think this is exceptions we will cover later. Okay, exception means okay, you don't want to delete the object, okay, because backup is incomplete and you say you wanted to destroy. Okay, but when your backup is not complete, why would you want to destroy? You will lose the data. Okay, so what you can do is you can throw some exception. Okay, when you throw some exception, this object is not deleted, some exception handling will happen. Then you can write some for loops here and come back and do the destroy again and again. Okay, you can do some other checks where we can find what can be the reason that this object didn't get destroyed. Some UI errors or warnings that we can show there. Okay, you can do certain operations. I hope you guys are clear on that, right? Why we can write some destroy functions or why we can how we can use this objects and all.
Yes.
Okay. Okay. More. Okay. So he has given some the same thing whatever I covered. He has given here in Geeks for Geeks. So it's the same. We can do it this delete of this objects. Okay. And why we use this variable? Okay. You have a argument passed by name X, and you don't want to mess it up in your operations. This variable with the same name coming in. So you specifically mention this and do this the same. And another important one is you can write something like this. Okay. obj1 dot set dot text, obj2 dot set y. I think this is not much important, but I'll explain you this, okay, if you guys want. So in your code, assume you create an object with instance with which has I mean you have an object which has two variables y, x and y, and you just initialize them. Okay. Suppose you want to change the content of x and y in a single statement. Okay, in a single statement, what you can do is obj1 dot set x 10 dot something dot set y dot 10 dot something. You want to do something like this. What you need to do, you can do is you have to write this function, make this function return itself. You have to make this object return itself. Now, now we'll see this definition. Now, if you see set x is this, what it does is it takes an argument a and copies the content of a into x, and then it returns this. When he says returns this, it is nothing but object one itself. So this whole code gets executed and will be replaced with obj1. Okay. Now obj1 with it what it gets replaced because you are just passing itself. Okay. Now obj1 dot set y. Now you are doing the same thing set y. So I'll just write this code so that you can. So what he has done is obj1 dot set x 10, set y as 20, and he has just printed the contents. So using single statement, he is able to make assignments of two like this, set x and set y. So you can write some functions because something like this. Again, you can do now y will become 10, okay, and x will become 20, okay. So see, x will become 20 and y will become 10. So on a same object, if you want to call multiple operations, like I can call set y again, set x again, and again, and so on. Okay, I can call this as many times as want on a single line. Okay, if I want to do something like this as much as times I want, I can write something like this. What it does is it takes the arguments that you are passing here, okay, and does the whatever arithmetic operations that you want to do. Post that it returns a this pointer. So what returning a this pointer means, it is nothing but it just returns the reference of this object. Okay. So what it effectively does is this gets iterated to this in the first state in the when it executes for the first time. Now the same thing gets once the second operation is done, then it will do the third operation. Now once the third operation is done, what it will do the fourth one. Okay. So every time what it is doing, it is calling this function and it is just returning the reference of the self object. Okay, so that's when you are able to make changes to the same variable by making multiple function calls. Now let's run and see what happens. Now if you see, the values are 4 and 1. So what was the last value that was set for x is 4. What was the last value set for y? It is 1. So this is the result. I hope this is also clear, right? You can use this pointer. This will this will just return the address of uh, the object itself, and on top of that you can do some operations. So now he has given some examples and all. Okay, so we can try this examples and see if everything is, you are able to understand things on it. Okay, I think whatever that I have covered is part of it. Chat. Okay, I think this is what I wanted to cover today. Maybe tomorrow I can cover inheritance and the multiple inheritance concepts. So far, any questions on this pointers or smart pointers or anything else?
Uh, I have one question.
Yes.
With this pointer, you have showed, right? By that only same function we can call multiple times, right? We cannot call two different functions.
This pointer will just basically. Can you tell the syntax what you wanted to us? So this is
I mean,
something which you can.
set x, set y is the same one function.
Okay, this one now. See, here the set x, set y are outside.
Yeah.
Okay, so now where do you want to write a code, here or here? I'm not able to get your question. So using this pointer, you said, can I call the function only once or not, right?
Yeah, yeah,
Okay.
chained function calls, you have written a chained function call, right? The application. So we are calling the set x, set y. Is it possible to call any different functions,
See,
or same
you
set of
can
functions we can call?
you can call any other function. From here, I can call set y also. So let's test
Okay.
this also. So this means on the same object you are calling. Okay. Now assume now I have removed this. Okay. I have just set x as 10. Okay. Now what will set x do? Set x will take 10 and assign it to x. And y, you are assigning some value as 3. Correct? You are
Okay.
assigning a
Yeah,
value
yeah.
as 3. So now at the end you print. So what should be the value? 10 comma 3.
3 years.
See, 10 comma 3.
Okay.
Y is 3, x is 10. Okay. But what is it that you cannot call is this. Now what will happen if you do this?
Clash.
Using x, I called X, it went here.
Yeah.
Now you're calling X
Again, it's calling.
here, here, here,
Yeah.
here. This is calling.
Yes, yes.
You can just write a condition if you don't want it to do it.
Yeah.
Then it's fine. It's like a linked list or something. If you are writing some iterations on a linked list, you can avoid
Yeah.
it. Okay. If A is not equal to 10, you are setting it else. See, you set
Yes.
it as 10, you pass it as 10. Since it is not equal, it is equivalent to 10, you are not calling this function. So the y will remain as it was. You are not overwriting 10 to 3. So the y
Yeah.
will remain what it was assigned here. Okay, so you can use this for recursion or calling other function. Basically, this is not actually required here. This is only required. Okay, this function is only required if you have a, both of them are same. Both the values are, both the names are same. Both the variable names that you have is same. That is when you would use this. Okay, so here the value pass this x, and I have a variable by name x. That is when I would call this. Okay, other cases I want to return the reference of this object. That's when you will call this. Okay, or another way is get my address. This one you can do using this. Using this, I can print the address of this object. Now let's see what he does. Now he print, with this I'm able to print the address of this object that you got created. Now let's verify it's the same. Okay, so now both this and this will have same value. See, now the address of obj1 is same as this function returning. Now what is this function is returning? This function is just returning this variable. Now what does this variable? It is just going to have address of the object on which you are doing some operation. Okay, clear, right? Any more
Yes.
doubts? Okay.
No.
Okay, guys. I think that's all I had for today. Do you guys have any questions from anything else? Or you guys want me to cover something else which you feel that you don't want or is not covered in this? Okay. So this operator which was missing was covered. Assignment operators, deep copy, shallow copy, they are covered. Operator overloading, they have covered. I think I have done plus and plus equal to I have done. I think rest are all same. Okay, maybe relational operators I need to explain. So this how you can compare two objects. Technically they are always same, but maybe if you want, I can cover this. If you are able to do write an operation for plus and minus, it is just the same. Okay, but when you would use it is what it makes sense. Okay. Maybe next class I'll start inheritance. Before that, if you guys want, I will cover this relational operators, overloading relational operators. Okay, friend function I didn't write. Okay. There's one pending. Okay, I'll cover this one. So you want me to go through C++ first and then start the Linux, right? That should be good for you guys, right? So because when I
Yes.
start writing code in the Linux, right, you guys should be able to understand what I've written. So that's the reason I'm starting with.
Yes.
Okay. Okay, guys. Thank you. Thank you all.
Yeah. Thank you.